this class I am going to talking about or discussing about counting techniques. Counting techniques. Counting means how we can count without counting. That means we count means what? 1, 2, 3, 4, 5. In this way we are counting. But here counting is done by formula. Using formula, shortcut way we can calculate values. Okay, this is known as counting principle or counting without counting. So basic thing is permutation and computation. Counting is based on permutation, factorial, everything. And it is a part of discrete mathematics. And as you know, discrete mathematics is very much related to computer science. Without mathematics like discrete math, applied math, we cannot complete our computer science course. So these courses are included in computer science, discrete mathematics. And this subject, permutation combination, it belongs to discrete mathematics. Okay. For simple example, counting techniques. In the film also, suppose there are 2 entrants and 3 exits. My question is, how many ways one person can enter the hall and come out of the hall? Can you tell me? There are 2 entrants and 3 exits. One person is to enter the hall and come out of the hall. Come out means through exit. Through entrance he will enter, and through exit he will come out. So how many ways a person can enter and come out? Can you tell me? 3, 4, 5, 6, any answer? 5. You see this one. This is entrance. There are 2 entrances, there are 3 exits. Okay. So the person enters in this way and come out this way. 1. This is 2. 3. This is 3. Then this way. 3 plus 3 is 6. Formula is choice for entry is 2 and choice for exit is 2. So just you multiply. That is 6. This is the answer. This is known as principle of counting. Principle of counting says if there are number of objects and choice for each is M1, M2, M3, like this, then you just multiply all the choices. That will be the total choice for all. Choice for all. That is known as principle of counting. Here there are entry is one object, exit is another object, choice for entry is 2 ways, choice for exit is 3 ways. So in this way you just multiply, that is the total way for entry and exit. Okay. Another question I am asking to count, how many ways 3 person can be arranged in a bench? Suppose you 3 are there in a line, you have to sit. How many it is possible? How can we arrange 3 persons? Well, anybody? A, B, C. A, B, C are 3 persons. A, B, C. They are to be seated in a line. How many ways it is possible? A, B, C is one choice. Another choice is A, you change the alter them, C and B. This is another way. So first way is A, B, C. Second way is A, C, B. Third way, you start from B, C, A, then B, A, C. This is then you start from C, A, B, and C, B. So there are 6 ways. There are 6 ways. If we want to arrange 3 persons in a line, there are 6 ways. What is the formula then? Just like previous example, you multiply 2 into 3, but what is here? For this, there is a formula. According to counting principle, what will be the formula? 3 factor. 3 factor. N factor. To permute n distinct objects in a line, there are n factorial number of ways. Okay. That is called permutation. Permutation equivalent meaning is arrangement. Permutation means arrangement. Achha. Let me quiz this question. Out of 3 persons, A, B, C, I want to arrange them in 2 seats. There are 2 seats, but a computer has 3 persons. How many ways I can choose them to sit in this 2 seats? I am repeating the question. 3 persons are there. They are to be seated in 2 seats. How many ways it is possible? Out of 3, 2 are to be at a time seated. So I can arrange them like this: A, B, B, A, then B, C, C, B, C, A, C, A, again 6 ways. Again, 6 ways. That means out of 3 person, if I at a time choose to sit or arrange, then there is 6. There is 6. But same question, selection. A, B, C. 3 persons are there. I want to select 2 persons. Okay. Some debate competition is there. 2 persons are to be selected from out of 3. Then how many ways it is possible? How many ways? 3 persons are there. 2 persons are selected. How many ways? Here it is 6 ways. Out of 3 persons, I have to arrange 2 persons at a time in a line. 6 ways are there. Here question is different. 3 persons are there, A, B, C. I have to select 2 persons. Selection. 3 ways. 3 ways. Either A, B are selected, or B, C are selected, or C are selected. Here you mark one thing. Here order has importance. First A, then B. First B, then A. But here A, B, A, same. Because 2 are to be selected. Who is first selected, who is second doesn't matter. Here order is not important. Here order is very important. So this is known as permutation. This is known as permutation, and this is known as combination. This is known as combination. Equivalent meaning, English meaning of permutation is arrangement, and equivalent English meaning of combination is selection. Okay. So formally we can define it this way. So theoretically, permutation equivalent meaning is arrangement. Here we use the symbol like this. This is called as n factorial. N factorial. N factorial means you multiply n, then n minus 1, n minus 2, up to 3 to 1. Then what is the value? That is shortcut way we can write n factorial. Okay. So similarly, 3 factorial means you multiply 3 up to 1, 3 to 1. This is 4 factorial. You multiply 4 into 3 into 2 into 1 sequential. That is 24 in this way. So factorial is a representation to represent big numbers in a shortcut way. Okay. And it is defined that 0 factorial. 0 factorial is 1. 1 factorial is 1. How it is possible? Is it possible? 0 factorial is 1 or 1 factorial is 1. Can we prove this? No. Because definition has no proof. Okay. Who invented this? Mathematician. He says that 0 factorial is 1, 1 factorial is 1. It is defined. On the basis of that we have calculated. So using this factorial notation, we can divide, or we write this PNR. PNR, that means permutation or arrangement of n distinct objects along a line. Taking R at a time. Taking R at a time. The formula is n factorial divided by n minus R. N minus R factor. This is called PNR factor. This can also be written as NPR in shortcut. NPR. That is permutation of n objects taken R at a time. In previous example, there are 3 persons. They are to be seated in 2 seats. 2 seats. So our answer was 6. Our answer was 6. How can we represent in this way? That is, out of 3, at a time 2 are to be arranged. 2 are to be arranged in 6. The formula is 3p2. 3p2 means the 3 factorial by 3 minus 2 the factorial. So that is equal to 3 into 2 into 1 divided by 1 factorial. That means 6. It is matching. The answer is matching with the previous answer. So this is the formula 3p2. Achha. How many ways we can select 2% out of from 3% 2 are to selected? What will be the formula then? Not this one. This is permutation. Permutation is different from combination. So for combination, the definition is like this: CNR. Sometimes it is written as NR. Another way of writing it is NCR. It is defined as factorial n, R factorial, n minus R factorial. Okay. So in previous example, there are 3 persons, 2 are to be selected. 2 are to be selected. So answer will be, according to this formula, out of the 2 are to be selected. So that is 3C2. Formula is 3C2. So answer will be 3 factorial, 2 factorial, 3 minus 2 factorial. So 3 factorial is 3 into 2 into 1. Here it is 2 into 1. So that is 3. Answer is 3. So when selection is there, out of 3, 2 are being selected. The choice is 3. Okay. So this formula matches with previous examples. Okay. So in this way, we can count using permutation and combination. We can apply this in another example also. How many people? 10 people can make handshake. How many ways? 10 people can make how many handshakes? 10 people. With 10 people, how many handshakes are possible? 5. Achha, with 3 people, how many handshakes are there? With 3 people, how many handshakes are there? Permutation or combination? Here, which formula is to be applied? Permutation formula or combination? Achha, for one handshake, how many hands are required? 2. Achha, available hands for handshaking. How many hands are available? 10 people, na? So how many hands are available for handshaking? 10 now. One hand. We are using one hand for handshake, not 2 hands. Okay. So 10 hands are there. So left is 10 hands are there. For available for handshake. In 2 hands, 1 handshake is possible. So here our calculation should be like this: out of 10 hands, how many ways we can select 2 hands? That much of a handshakes are possible. For one handshake, 2 hands are required. Out of 10 hands, how many ways we can select 2 hands? That is the answer. So answer will be 10C2. 10C2. 10 people are there. 10 hands are used in handshaking. For one handshake, there are 2 hands are needed. So answer is like this: 10C2. Select. We have to select 2 hands. So the answer will be 10 factorial by 2 factorial. 10 minus 2 factorial. So that will be 10 into 9 into 8 factorial is over here. This is 2 factorial. This is 8 factorial. 8 factorial cancel. So this is 5. 5 and 9. 45. Can you imagine? 45 handshakes are possible. With 10 people, how many handshakes are possible? 45. Okay. Achha, another simple question. In a square, how many diagonals are there?
2, 4.
In a square, how many diagonals are there?
2,
1, 2. How many diagonals are there?
2.
1, 2. 2 diagonals are there. Achha. Between 3 points, how many lines we can draw? Maximum.
3.
Between 3 points, how many lines we can draw? Maximum lines. 3.
3.
1, 2, 3. Achha. in 4 points, not 2 or 4 here. How many lines we can draw? 6. How many lines we can draw? 6. To draw one line, we need 2 points. We need 2 points. Out of 4 points, how many ways we can select 2? That much of lines we can draw. So with this square, how many lines we can draw? 4. 4 sheet. Formula is 4 sheet. You subtract the sides. How many sides are there? 4. So if you subtract 4, then remaining is diagonal. Actually 2 diagonals are there. Total lines are 6. Out of these 4 are sides. You subtract sides. So answer will be 4C2 means 4 into 3 by 2 minus 4. Yes, that is equal to 6 minus 4. That is 2. Actually it is 2. 2 diagonals are there. Okay. Similarly, if I put question like this, in a hexagon means, sorry, how many diagonals are there? Here, how many diagonals are there? 1, 2, 3, 4, 5. How many diagonals are there? In a hexagon, how many diagonals? So formula in this way, formula will be 6C2 minus sides are 6. This will be formula. So that is equal to 6C2 means 6 into 5 by 2 minus 3 into 5 minus 6. 15. 15 minus 6. 15 minus 6 9. So here 9 diagonals are there. We are missing something. Which one is this? 1, 2, 3, 4, 5. Here 1, 6, 7, 8, 9. 9 diagonals are there. Actually 9 diagonals.
ଗୋଟେ ପଏଣ୍ଟ ରୁ ପୁଣି ଯିବ
ତଳ point
ତଳ ପଏଣ୍ଟ ରୁ ଆର ଦିଟାକୁ ତଳ ପଏଣ୍ଟ ରୁ ଉପର ସାଇଡ କୁ
हाँ.
So 9 diagonals are. So formula is correct. So actually using